In this video, I'm going to talk about auto transformer. Auto transformer is works based on the similar to the two winding transformer. The main thing is it is a single winding transformer. Okay, auto transformer is a single winding transformer. It is used mainly to increase or decrease the voltage in small quantity like 12.8 kV to 13.2 kV or 110 to 120 volts, something like that. In the auto transformer, energy is transferred by induction principle as well as conduction. Okay, induction is nothing but, if you look at the two winding transformer, there is no relation, there is no connection between primary and secondary. Okay, there all 100% of energy is transferred through induction. But here in the auto transformer, these two windings are combined and made it as a single winding. Okay, now if you look at this, there is the electrical connection as well as these two windings are placed side by side. So there is a induction principle as well as conduction principle. So energy will be transferred through induction principle as well as conduction principle. Advantage of auto transformer: less copper is required and high efficiency compared with the two winding transformer. Smaller in size, less leakage reactance because smaller in size, and the coils are placed very close by, and the better voltage regulation. So auto transformer has so many advantages. The only disadvantage it has is no isolation between primary and secondary. Okay, so because of this disadvantage, we are not using or we are not replacing regular transformers into auto transformers, because when it comes to the regular transformer, as I mentioned, there is no electrical connection between the primary and secondary. If something goes wrong here on the secondary side, that is limited to the secondary side, it will not transfer to the primary side. Okay, so we are saving a lot of equipment on this side. Okay, nothing happened to the primary side equipment. Where if we look at the auto transformer, okay, if something goes wrong on the secondary side, there is electrical connection automatically transferred to the primary side. So that is the reason the two winding transformer is also called isolation transformer. Okay, so here it is not isolating anything, so that disadvantage, that's because of that disadvantage we are not using auto transformer instead of a two winding transformer. Now where do we use the auto transformer? I'll give you a simple example. Here is a power plant where the voltage is 13.3 kV. Now that 13.3 kV is transferred to a load center nearby by a long line. So if the load is like 5-10 miles, probably they're not going to step it up to 33 kV and step it down to 13.3 kV. Usually if it is close by and the power plant is only the load center and the power plant, the rating is same, like this is generating 10 megawatt and the load is also 10 megawatt. We don't need to spend a lot of money on the substation. Now this long line, because of the long line, what happens, the voltage will drop. Say this is 10 miles or 5 miles. Okay, this long line will have some resistance. Because of the long resistance, assume that there is a 0.5 kV voltage drop. So the voltage, when it reaches here, you will see only 12.8 kV. Now this transformer rating is 13.3 kV to 120 kV, sorry, 120 volts. Now you are giving only 12.8 instead of 13.3. So what it will do, instead of 120 volts, it might give you only 1118 volt, 2 volts less than the rated value. Okay, so that is not acceptable by the customer, because all our equipments are designed, basically they're designed 110 to 125 volts in the range. But if you constantly giving less than 110 volt, then the damage is going to be get damaged. Okay, and the quality of that, say for example, if you're watching a video or TV, okay, the TV required 120 volts and you're providing only 110 or 105 volt, then the quality of that video is not good. Okay. I'm from India. I want to share this experience with you guys. I live in a small village. So like 25-30 years ago, at that time we don't have power supply to every home, so there were only a couple of TVs, but at the same time our village is a little bit far away from the transformer. Okay, there was one transformer for 3 villages. In the United States we have one transformer for 3 to 4 homes. That's the power difference or energy difference we use here and there. Anyway, since my homes are little far away from the transformer, we always see the voltage drop. Okay, especially in the evening time. So on Sunday evenings we used to watch, there was only one channel run by the government at that time. Now there are thousands of channels, but at the time there is only one channel. So, and they play a movie on Sundays. So even though the voltage was low, we used to turn on the TV, turn off every other load and try to watch the TV, but still the screen we were watching is always flipping. Okay, still we keep watch that movie anyway. Anyway, that was my experience. So here, if we have the auto transformer, what we can do, we can place the auto transformer right here. Okay, and we can step it up. So here we can give 12.8 kV right there, and it will give you 13.3 kV. Okay, by using auto transformer, I'm already stepping it up. As I mentioned, compared to this 2-winding transformer, this transformer is way less expensive. That is the reason we are using auto transformer here. Even if something goes wrong, it will transfer on the both sides, but at the same time it won't go towards the load on the secondary side. And this auto transformer is placed very close to the regular transformer. Okay, so that's the reason. So no isolation is not an issue for us. That disadvantage doesn't apply here because I already have a regular transformer just besides it. Okay, so that is the main application of auto transformer. Even in olden days, you might have seen a DC power supply where you can change it to 6 volt, 12 volt, 15 volt, 9 volt, something like that. I believe that is also an auto transformer. Nowadays I haven't seen them, but in olden days there was a device where you can get different voltages, DC voltages, to charge your electronic goods. Now here also we have 2 types of transformers. One is step up transformer, auto transformer. Another one is step down auto transformer. Okay, I'm drawing these 2 lines assuming that this is an ideal transformer. So if you look at here, which one has high voltage? For sure this V2 has high voltage because more number of turns. Here this is N1, N2 and V1, V2. Say for example, if N1 is 100 turns, N2 is going to be around 10 turns. Okay, so now what is my V2 over V1 ratio? V2 over V1 equal to V2, I have total number of turns, N1 plus N2 divided by the primary has only N1 turns. Okay, so this is the transformer ratio for an auto transformer. At the same time, I'm assuming this current is I1, current entering there, and I2, current leaving there. So based on this must be equal to I1 over I2. This is the ratio of the auto transformer. So basically if I give 100 volts here, okay, how much voltage am I going to get here? Probably 110 volt. Okay, as I mentioned, it is going to step up or step down a little bit. When it comes to the step down, you can do the same thing. So here is my two winding transformer. Okay, so here I'm giving V1, say this is 10 turns N1. This is N2, V2 and V1. Here is my I1 and I2. In this case, what is my relation? V2 over V1 equal to number of turns N2 over N1 plus N2. Okay, and this is valid for I1 over I2. Okay, so this is a step down auto transformer. Here this winding is called common winding since it is common for both primary and secondary. Okay, this is a common winding, and here this winding is called series winding. Okay, that is series winding. Same way here, this is common winding and series winding. Now I1 current comes there, it's going to split in two parts. Here is I2, and this common current, some books indicates I0, some books indicates IC, so you can use any one of those two. Okay, and I1 equal to IC plus I2. Same way here, I1 equal to, so IC current is common current, IC plus I2. Here is an example. In this example, he's saying that there is a 60 volt ampere, 120 volt by 10 volt, 60 hertz, a two winding transformer. Now we are converting that into a 120 volt by 130 volt, 60 hertz auto transformer. Find the rating of the auto transformer. So if you look at two winding transformer, okay, here is a two winding transformer. Now he gave us 60 volt ampere, and the primary is 120 volt and the secondary is 10 volt. This is a regular two winding transformer. Since the rating of transformer is given 60 volt ampere, now can you tell me what is the current the primary winding and secondary winding each can carry? The primary winding I1 equal to S equal to V1 times I1 prime, but here I'm using the real numbers, so don't worry about the prime. So I1 equal to 120 over 60 over 120, that will give me 0.5 ampere. Okay, and so this is 0.5 ampere. This one can carry, which is V2 I2 conjugate, so I2 must be 60 over 10, that is 6 ampere. So secondary can carry up to 6 amperes. So the manufacturer, when they manufacture this transformer, they use the gauge of the wire, the size of the wire. They make sure that the secondary can carry up to 6 amperes and primary can carry up to 0.5 amperes. Now we are using this two winding transformer into a single winding auto transformer. Okay, so here this is what we're going to have. Here is my V1. Okay, he wants to supply 120 volt. Okay, so basically this is N1 and N2 here. If I choose this is N1, this is N2. So for sure here we will end up having 120 volts because of this and 10 volts because of this, so we'll end up having 130 volts here. So remember, from the first part we found that this can handle up to 0.5 ampere and this winding can handle up to 6 ampere. Okay, so the current, this is going to act like a source. The current supposed to be entered there 6 ampere, or current is going to go in this direction 6 ampere. Okay, so what is the current coming out here? So 6 is going up, 0.5 is coming down, so it must be 6.5 ampere. So 6.5 ampere is going to start from there. Out of 6.5, 0.5 is going to go down, and 6 ampere is going to go through the load if it is fully loaded. Now you can see out of 6.5, 0.5 coming down, 6 is going there, and 6 amperes is going through the N2 and 0.5 coming through the N1. So total 6.5 is going towards the negative terminal of the source. Now what is the rating of the transformer? S must be V1 times I1. I can clearly see V1 is 120 volt and I1 is 6.5, or I can say V2 I2. V2 I have 130 volt and the current it is carrying 6 amperes. So the rating of this S is 780 volt ampere. See, by using a simple connection, all I did is I used the external wire. I connected this to this. Okay, by using a simple connection, I made this 2-winding transformer into an auto transformer. When I made that, this 60 volt ampere transformer, the rating of the transformer is only 60 volt ampere. Now when I made it as an auto transformer, it became 780 volt ampere. So almost how many times bigger? 13 times bigger than the original transformer. So that is the reason when it comes to the auto transformer, the size is small compared to the regular transformer, and less copper is used, less expensive, all those positive things. Okay, now the next question I'm going to ask, why the transformer is rated at in volt ampere, not in power watts. The reason behind it is, when the manufacturer manufacturing the transformer, he doesn't know what kind of load you're going to connect it at your home. Even if you look at your home, most probably your AC is an inductive load, your heater is a resistive load, your microwave I believe it is it's an inductive load, your refrigerator inductive load, most of the all the fans are inductive loads, most of the lights you can say resistive, but with all the electronic components nowadays I think it's also a little bit inductive load. So you're going to turn on your load at different times. Okay, so sometimes your power factor is 0.8, sometimes it is 0.9. So you don't know what power factor you have. Same way manufacturer doesn't know what kind of power factor you're connecting. So that's the reason to rate the transformer, they always rate it in kVA or volt ampere, in S, in apparent power instead of active power. Okay, I'll stop this video here. Probably I'll solve 1 or 2 examples based on the auto transformer in the next video. Thank you.